Okay, we are reviewing homework 2.1. Let's start off by taking a look at number 1. Number 1 asks you to list all the elements of the following set. It tells you to use set notation. And the listing method. To describe the set. We're looking at the set of all counting numbers less than or equal to 2. It has these braces, and you are just putting what goes in the inside. Okay, so we are looking at really important to understand a couple of definitions. Right, listing method means list everything. Right, so that means list everything. We want to list everything that is less than or equal to 2. Right? So everything that's less than or equal to 2. So if we look at our number line, here's 0, here's 2. Everything less is over here. Right? But then we have counting numbers. Right? And it's important to understand what counting numbers means. Counting numbers, right? Think of a child when they start counting. Counting numbers, child starts at 1. So counting numbers are like 1, 2, 3, 4, 5, and so on. So we don't have to include these negatives, right? Looks like all we're going to do, the ones that are less than or equal to 2, means we're just going to include 1 and 2 as our answer. Right? Listing method, we listed all of them. Counting numbers, 1, 2, 3, 4, 5, 6, 7, so forth. Which one of those are less than or equal to 2? Well, 1 and 2 is. So nice example to number 1. Number 2, list all elements of the following set. Once again, use set notation and the listing method. We have braces, we have 8, 9, 10, and then after that a comma, we have 3 dots, another comma, 16. All right, and your problem looks like this. You got your braces, you have 8, 9, 10, comma, right? Then you have to put some stuff in here, followed by a comma, and then 16. So once again, just understanding listing method means to list all. Right? These 3 dots indicates that there's more. Right? Specifically more elements. Remember, elements is just whatever is inside the braces or the set. All right? So these dots mean that there's more numbers, right? Look at the pattern. The first one is 8. The second one's 9. The following is 10. So then the next one would be 11, then 12, then 13, then 14, then 15. And we stop there because then it goes to 16. So those 3 little dots indicate that there's more, right? That there's more elements in there. And elements are the things inside the set. All right, so that's number 2. Number 3, list all elements of the following set. Once again, use set notation and this listing method. All right, we have these braces, we have X, then we got this little vertical line. It says X is an odd integer between -2 and 5. So now we're just looking for the odd integers, right? The odd ones, right? What are the odd integers? Well, it's, right? Remember, integers are negative and positive numbers, right? So, and also includes 0. So integers, right, is like 0, 1, 2, 3, 4, 5, 6, right? On the other end, right, -1, -2, -3, -4, -5, -6. But we only want the odd ones between these two numbers. Between them, it does not say includes. So we have our -2, right? We have our 5. What are the odd ones? Well, this is an odd one. That is an odd one. That is an odd one. Right? So those would be our odd numbers between there. All right? So they start you off with the braces because the braces always means set. And all you got to do is put those numbers in there. -1, 1, and 3. So a nice example to number 3. Moving on. Number 4, identify the set as finite or infinite. All right, so they give you the set with these elements. Remember, whatever's inside the set is called elements. Right? So they give you this set with these elements in the inside. Is it finite or infinite? So remember, finite means that you can count the amount of elements. Infinite means that you cannot find the amount of elements, let's say for both of them, in a set. Right? So can we find the amount of elements that are in here? Well, we can, because it has a starting and it has an ending, right? This is the first number. This is the last one. If we wanted to, we could do some work and find those, okay? And then once we find them, we can count how many we have in total, right? So this is an example of a finite set, all right? Because we can find the number of elements. We can count how many there are. You can tell me that there's 6, 7, 10, 20, 100, 200, 600. You can tell me that there's 900 elements in there, right? So you can give me a whole number to identify how many elements, right? So it's finite because the number of elements is known, right? Or in other words, is a whole number. All right, so a nice example there, number 4. How about number 5? Is the set finite or infinite. Right, so start off with open braces because it's set. Now we have 12, 24, 36, 48, dot, dot, dot. We just talked about the definitions of finite or infinite, right? Taking a look at infinite, right? Infinite specifically says we cannot find the number of elements in there. Right? You cannot find the number of elements in there. And if we take a look here, okay, it's 12. It looks like they add another 12 maybe. Then it looks like maybe they add another 12, they add another 12. But then it doesn't stop. Remember, these 3 dots means that there's more elements. And also notice that there's no ending, which means it never stops. It never stops, right? It goes to 1 million, 5 million, 8 million, 100 million, a billion, a trillion. So with this example here, right, there is no ending. So we cannot, right, find the amount of elements in the set. Therefore, this is infinite, right? We cannot find that whole number, right? Okay. Number 6. It says for set B, right? It wants you to determine n of B. So they want to know what n of B equals. Remember, this means cardinal number. All right, learned this in Mr. Warren's class. Remember, cardinal number, the amount of elements in a set. Well, our set B has this set. How many things are in there? There is none. Therefore, our answer is 0. There are no elements in that set. Nice example, number 6. Number 7. Same thing. Find the cardinal number. All right, let's go with our first one. Set A has this: 100, 101, 102, 103, dot, 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 comma, 127. Right, so how can we find the amount of elements that are in here? So, let's take a look at a really easy example. All right, and we'll come back to this. What if I said that A has 1, 2, 3, 4 elements? How many do we have in there? Well, this is easy. We can count, right? Or let's change it up. Let's not do numbers because sometimes that's a little easy. All right, but same idea. Let's just say it has these letters: A, B, C, D. Well, how many things do we have in there? All right, we have 1, 2, 3, 4. All right, so this answer is 4. All right, this answer is 4. So that's what we're doing here, but maybe not so easy with this example here, right? But how can we do this, right? How can we do this, right? What if we did this number and that number and we subtracted it? Well, that gives us 3, but the answer is 4. But if we add 1, it works, doesn't it? Is that always the case? Let's take a look. Here we got 4. Let's do the same thing. Here we got 1, 2, 3, 4, 5, 6, 7. How many things do we have in this set? We have 7 of them, right? There's 7 things. Well, what happens if we work with the first number and last number? What's 7 minus 1? Well, that's 6. Well, how can we get that? Well, here we added 1, so let's just do that again. Let's add 1. We can do the same thing then here. Remember, these 3 dots means that there's a lot more stuff in there. Right? There's a lot more going on there. All right, there's more elements. There's 103, 104, 105, 106, 107, 108. It keeps going. So why don't we do 127 and 100? And we subtract. Right, we subtract that, we get 27. But what do we have to do now? Just like these other examples, let's add 1. Means that the cardinal number of this example is 28. Right, so a nice example there. All right, let's take a look at one more example, B. Right, what if I told you now that we're just working with evens, right? How about this example? Well, we know there's 3 things in there, so that means that cardinal number is 3. But how can we do it the same way that we just did, working with the first and last one? Well, we subtract 6 minus 2. Right, we do 6 minus 2. It gives us what? 4. But how do we get this 3 there? Right? How do we get 3 from that? Well, we take away 1. Right? That's how we can get that 3. But let's see if it works again. Right? Because our whole goal is to see if we can find a way to always make this work. 2, 4, 6, 8. What's this cardinal number? Well, how many elements do we have in there? 1, 2, 3, 4. We have 4 of them in there, right? But does that work if we work with the first number and last number? What's 8 minus 2? All right, that's 6. Take away 1. Oh, that doesn't work, which means we can't do that technique of taking away 1. All right, looks like we're going to have to do something a little different here. All right, so what can we do here? Well, notice that these are evens. 2, 4, 6 even. 2, 4, 6, 8 even. All right, so let's go back. We know that this answer is 3. Right? We are working with the first and last. And we're subtracting. That gives us 4. All right? But because they're evens, it's like we're skipping a number. And because we're skipping a number, now that 4, we cut it in half. Right, we're doing every other number. So 4 divided by 2 is 2. And what were we doing at the very beginning over here? We're always adding 1, adding 1, adding 1. So why don't we still do that now? Plus 1, hey, look at that, it's 3. All right, take a look at another example. Let's go back now. 2, 4, 6, 8. All right, work with the first one and the last one. subtract just like we did before. All right, so that gives us 6. Once again, because we're doing every other number, we divide that by 2. Gives us 3. And like always, we add 1. Hey, look at that. That works because we have 4 things in there. And that also gives us 4. So now we should be able to do with anything. 117, 119, 121, 317. Now it looks like we have odds. 117, then 119, then 121. They're odds this time. Right? But it's still the same idea. Right? So we work with the last number and the first number, and we subtract. We do 317 minus 117. Right? That gives us 200. And once again, because it's not every single number and it's every other one, we divide that by 2. Which gives us 100, and at the very end we add 1. So that tells us that the cardinal number of this one is 101. So some nice examples. Looked at problems number 1 through 7 on your homework here.